Good morning, everybody. In this video, we're going to find out the total energy of a satellite in a circular orbit. So, we have a satellite that is moving in a particular orbit around the Earth. So, what we going to calculate is when I say the total energy, that means we're going to calculate the kinetic energy plus potential energy. That is the total energy. So that's we're going to find out the kinetic energy and potential energy. But in order to find out the kinetic energy, we need to understand what is the speed of the satellite in this particular orbit. So let's first find out the speed of the satellite. So this satellite is moving in this particular orbit. How come this satellite is moving into this particular orbit? Let's try to understand this. So as this satellite is moving into this orbit, there must be a force. Without a force, nothing in the universe can move into a circular orbit. There must be a force. And as this one is moving into a circular path, the gravitational force by the Earth onto the satellite is providing the necessary centripetal force. Okay, so the gravitational force in this case provides the necessary centripetal force. So that's the equation we have to write down first. So this is the gravitational force, and this is mv square over r is the centripetal force. Okay, so once you write down this equation, then life becomes so easy to find out the speed of the satellite. One more time, as this satellite is moving into a circular orbit, the gravitational force by the Earth onto the satellite provides the necessary centripetal force. That's what I have written down. What is the formula for the gravitational force? You know, by the Newton's law of gravitation, G m over r. Here me is the mass of the Earth, that's the mass of the satellite, and r is the distance between the Earth and the satellite. Whenever we measure the distance between the two objects, it must be measured from the center to the center. Okay, from the center of the Earth to the satellite. That's the r. M is the mass of the satellite, because only the satellite moves. The Earth does not move at all. There must be a slight fluctuation, but insignificant. So that's the mass of the satellite. V is the orbital speed of the satellite, and r is the distance between them. So the mass and mass cancels out. So if we solve for the speed of the satellite, that's the equation we get. So once we know the speed, we can calculate the kinetic energy. So the kinetic energy would be half mv squared. That's the formula for the kinetic energy. And we have solved, or we have found out, the equation for v squared. So simply plugging v squared as this value here, then we get the kinetic energy equation, G me m over 2r. Remember, kinetic energy is always positive. Kinetic energy can never be negative. So it's always positive. Once we have calculated the kinetic energy, let's calculate the potential energy at this point. So you need to remember the equation for the potential energy. And here I am writing down the potential energy equation. Negative G, m is the mass of the Earth, m is the mass of the satellite, and r is the distance between them. That's the equation. So once we have the kinetic energy and the potential energy, the total energy would be simply the summation of the potential energy plus kinetic energy. So let's write it down. The potential energy is this number here. So I'm simply writing down here. And the kinetic energy is Gme m over 2r. And if you do the math, you'll get this number here, Gmem over 2r. And I'll explain a few terms here. So the total energy is negative. So what does this mean? That means whenever the total energy is negative, that means the satellite is bound to the Earth's gravitational attraction. it cannot leave the um, so that means this satellite is bound to it. Okay, or in order to make it unbound, that means when I say, let me first explain this one, what is meant by bound and unbound. So unbound means how much energy you have to put into this satellite just to make it infinitely distance apart. When the distance between this satellite and the earth is at a very very large, we call infinite, then it becomes an unbound system. There is no longer attraction between them. That we call as an unbound system. So whenever the total energy is negative, that means it is a bound system. That means the satellite is bound to the earth by the gravitational attraction. And this number also tells you that if I supply this much energy to the satellite, then it will be infinite distance apart. Or in other words, in order to increase the gap between the earth and the satellite to infinite distance, then the amount of energy required will be this energy. Okay, that's the total energy. The first thing, that if the total energy is negative, that means the satellite is bound to the earth. And also, what does this magnitude tell you? This magnitude tell you that in order to move the satellite infinite distance apart from the earth, you have to apply this much energy. And the other information you need to understand here is the look at the magnitude, simply magnitude of the kinetic energy and potential energy. Kinetic energy is 1/2 of the magnitude of the potential energy, just the magnitude. And at what point, and I suggest you to write down these important points here. Now, if you look at the potential energy, at what point you will have the maximum potential energy? The maximum potential energy will be at infinity. Okay, because at infinity you will have this number as a zero number. And if you come closer and closer, this number will be -20, -30, -40. It's a negative number, so it is a smaller. So the maximum will be at infinity when the potential energy is 0. If you come closer and closer to the Earth's surface, the magnitude will be greater, but it will be negative. Okay, so that's how we find out the total kinetic energy and the total potential energy of a satellite. If you have any questions, write to me and I'll get back to you. Before you leave, do not forget to subscribe, like and share the channel. Thank you very much.